In question number 5, which is technically on the next page, they're going to ask you some true-false questions. And basically, it's your job to just check the two key parts of the definition, the specific term, which is what we call the first part, and the actual recursive formula, which we call the second part. And we just want to make sure that both parts work. If even one part doesn't work, then we can say immediately that it is false. And if both parts work, then we would say it's true. So here's an example. The first thing it gives you is that t of 1, the first term, is 22. So I would look at this and say to myself, oh yeah, the first term they give me is 22. So that seems like it checks out. That makes sense. For example, in letter B, they're saying the third term is 32. That checks out. So you don't really have to look too far for things. Just kind of look at the surface value and say to yourself, is that really the first thing they're giving me? Or the third thing they're giving me? Or whatever. Just take it really literally. The next part is honestly all kind of the same no matter what you look at. It all says t of n plus 1. They all say t of n. But it's what comes after the t of n, or sometimes before. It just kind of depends. But it's what's happening to t of n that matters. In this case, the sequence pattern is supposed to be plus 11. So that's what I'm looking for. If I do start at 22, is the next one going to be adding 11, and then adding 11 again, and then adding 11 again? And it looks like that works, because 22 plus 11 is 33, plus 11 is 44, plus 11 is 55, so it seems as though this is true. You don't have to worry too much about the explain or fix part. That part you can skip. It's just mostly a basic understanding for now. So in letter B, let's do the same thing. We've already checked that the third term really is 32, so that seems okay. That passes master. And then we look at the next part and focus on what's happening to t of n. The part that's happening to t of n is plus 4. So we're saying, okay, does this pattern add 4? Well, 2 plus 4 is not 8. And 8 plus 4 is not 32. 32 plus 4 is not 128. It looks like this couldn't possibly work. This seems like it's false, because adding 4 does not appear to be the pattern at all. Now, you could prove it to yourself by plugging in the equation. You could say t of, let's just use what they give us, 3 plus 1 equals t of 3 plus 4. And then we can check that t of 3 plus 1 is t of 4 equals t of 3 plus 4. And then I could plug in some actual numbers here. T of 4 is the 1, 2, 3, 4th term, so 128 equals t of 3, which is 32 plus 4. And that's not true. 128 is definitely not 3 times 2 plus 4. So we can tell that is not true, therefore it is false. And if you had to explain or fix it, this would perfectly suffice as an explanation. And to fix it, you could ask yourself, wait, if it wasn't plus 4, where did they get that from? Were they even close? And it does seem like they were on the right track. Times 4 would have worked. So if we would just put a times sign instead of a plus sign, it actually would have been fine. So you can do the explain or fix part if you want to, just to try to prove to yourself why it could have worked and try to fix what went wrong, but you don't have to. Right now, just focus on whether something is true or false and get the sense of the two important things that they give you. The specific term to start counting from, and the actual recursive formula that tells you the pattern to get the next terms.